Okay, so here's the solution to the second circuit. We're given three batteries in a row. They are hooked in what's called series, and their voltages add together. So 4 plus 4 plus 4 is 12 volts. So these three batteries can be thought of as one battery that it's actually 12 volts. Why is that true? Because if we think about voltage like height, these batteries are staircases that are adding height. So 4 volts on the first battery, and then 4 volts of height on the second battery, and then 4 volts of height on the third battery. Okay, so we've got 12 volts. The red dot down here is the same as this location over here. So choosing this spot, and we're going around the circuit like that. Okay. Then we encounter a drop, a voltage drop over the resistor R1, and a voltage drop across the second resistor, the 20 ohm resistor R2, the third resistor, 10 ohm resistor, there's a voltage drop across that, and the fourth resistor is an 8 ohm resistor. There's a drop across that as well. Okay, so the first thing to do is to apply Ohm's law over the whole circuit to figure out how much current is coming out of the battery. Okay, so we're going to use Ohm's law. So one way of writing Ohm's law is that the current coming out of the battery will equal the total voltage. So let's call that V total, or the V of the batteries. We're going to be treating these three batteries as one 12-volt battery divided by the resistance of the whole circuit. Now, there was only one resistor in the last circuit. Right now, there are 1, 2, 3, 4 resistors. So when resistors are in series, they add together their resistances. We're going to call the total resistance here R equivalent, REQ. Okay, and if you watch a video on resistors in series, they'll teach you how to add resistors in series. Basically, when resistors are in series, they just add together. So the current in the battery, the current coming out of the batteries, I mean, is going to be the 12 volts here divided by the total of these resistors. So 10 plus 20 is 30, plus 10 is 40, plus 8 is 48. Okay, so 48 ohms total. 10 plus 20 plus 10 plus 8. The current will be 12 volts divided by 48 ohms. That's 0.25 amps. Great, so I know that coming out of here I've got 0.25 amps of current. So the direction of the current would be in this direction, and 0.25 amps of current. Is that current going to split anywhere? As that charge flows through the wire, it's not going to split. So everywhere in this this loop, this series loop, we've got 0.25 amps of current. Okay, and the reason for that again is because the current doesn't split, doesn't have any choices. So all of the current has to go through this one path. Right, so the current through the battery is the same as the current through R1, the same as the current through R2, R3, and R4. Okay, so we can make a note of that. So basically we can say I1 is 0.25 amps. We can say I2 is 0.25 amps, so on and so forth. They all have current of 0.25 amps flowing through them because the current has had no choice. Okay, so now we need to figure out what is the voltage drop across each of these four resistors. To do that, we're going to use Ohm's law. Again, this is a good visualization of it. It drops a little bit on R1, a little bit on R2, a little bit on R3, and a little bit on R4. We know what the resistance is, so R, and we know what the current is, I, flowing through each one. So we can say V1 equals I1 times R1, 0.25 amps times 10 ohms. So V1, the voltage drop across resistor 1, is going to be 2.5 amps. Nope, sorry. Volts. V2 is I2 times R2. The voltage drop here is going to be bigger because the resistance is bigger, the current is the same, 5 volts. The voltage drop in resistor 3 is going to be I3 times R3, 0.25 amps times another 10 ohm resistor, so 2.5 volts of drop there. And V4, I4 times R4, 0.25 amps times 8 ohms, that'll be 2 volts. Okay, let's just double check something here. So I started by adding plus 4 volts, plus 4 volts, and plus 4 volts. So I was up to 12. Then resistor 1 used up some voltage, or had a voltage drop across resistor 1, minus 2.5 volts. Okay, then minus 5 volts on resistor 2, and then minus 2.5 volts again across resistor 3, and minus 2 volts on resistor 4. All right, and if we added all these together, we should get a drop of 12 volts. Well, 2.5 and 2.5 is 5, plus 5 is 10, plus 2 is 12. So there was 12 volts of supply, 12 volts of drop. So once we get back to the same point where we started, the voltage comes out even. You can double check your circuit by going to the website PHET, and you can create a circuit. So let's create a circuit here. Battery, battery, battery. Let's make a wire there. And let's just put a resistor there. And another resistor here. Okay, now we can mess with all these values. When we connect this up, we see that the current flows. Now these are the electrons. That's conventional current. And it's going through. But everything's wrong. We need to change these voltages. So each of these were 4 volts. We'll change that to 4. We'll change that to 4. And that becomes 4. Whoops. This was a 10 ohm resistor. This one's a 20 ohm resistor. So 20 ohm resistor. 10 ohm resistor. And an 8 ohm resistor. Oh, why in the diagram did they look like this, but in the PHET they look like this? It's because there are 2 different views you can use. Regular view, schematic view. Okay. So now we have the same circuit. Okay. Great. And now we can check out some things like, let's start with the current. So the current, let's check the current, 0.25 amps, 0.25 amps, 0.25 amps, 0.25 amps, 0.25 amps, everywhere it's 0.25 amps. Good. And the voltmeter, okay. So how much gain across these batteries? Yeah, 12 volts. How much drop across the 10 ohm resistor? A drop of 2.5 volts. How much drop across this resistor? A drop of 5 volts. Okay. How much drop across this resistor? 2.5 volts of drop. And how much drop across this resistor? 2 volts of drop. Those are the same as what we had. Okay. Hope this was helpful. All right, take care.